Today we will discuss about training session for air conditioning and ventilation system. Okay, so this package is a HVAC discipline. Okay, so you have a air conditioning and ventilation. Then we will talk about smoke management. Then we will talk about chilled water system. Okay, there are 3 design courses in the HVAC discipline, and also for the plumbing you have a water supply design. Then you have a drainage design. Then you have a fire system design calculation. Okay, so these are the mechanical system courses what we offer. Okay, so when you start with the air conditioning design calculation, you have a topics like we will discuss about introduction in air conditioning and ventilation system. Then we have an architectural package. Okay, we have a design basis report, HVAC room data sheets. Then we have a codes and standards. Okay, then we have a heat load calculations for fan call unit AHU as per guidelines. Okay, so whatever we discuss, whatever we teach, it is all as per the guideline. Okay, say for example, if you are working in one of the project, okay, you should know that what is the design basis, what is the minimum requirement for the design requirements. Okay, so that is given in the guideline. Okay, then for the fresh air ventilation calculation, we will follow as per ASHRAE standard, right? Then we will be talking about AC ventilation calculation or air conditioning calculation for the server rooms or like data halls. Okay, then you have a generator
Can I ask
ventilation
one
system.
question, please?
Yeah, you can. Yes.
See, for the FAHU, fresh air handling unit,
Okay.
what I found that we are considering the weather condition 35.3 and 30.6 in my
Yes.
many
Correct.
of the
Correct.
project.
Yes. Yes.
And this is called at evaporation condition.
Okay.
And generally, if I will see the weather condition, which is 46 degree and 29.4 or something like this, close to 30 degree.
Okay.
So
Okay.
why we are considering for the fresh air this value and evaporation condition?
See, when you consider 34 and 32 degrees Celsius, okay, you have a more humidity in that particular weather properties, right? More humidity.
Yes.
So
Yes.
when you say the dry bulb temperature and wet bulb temperature, when you say which is when you say very closer, so that means that you have a more latent heat, right, or more the moisture content in the air. Okay, so that means you require more heat, more energy to bring it down the conditioned space. Okay, so there is a calculation. If you can do it based on 46 and 29 degrees Celsius, and also you can do the another calculation for 34 and 32 degrees Celsius. So when you calculate with these two different equation, you will really find out the total heat load is above for 32, 34, 32, and lesser for 46, 29.
Yeah,
So
yeah.
that also we
This
will
one I
discuss.
have. Okay, fine.
Okay,
This
so
is
that
very
means
interesting.
you have a more load on the particular weather properties to bring it down to the your conditioned space. Clear? So that also we will do the calculation. See, normally whenever you do the fresh air calculation as per ASHRAE 62.1, what you will do basically, you will
Yes.
calculate the airflow rate, right? For the supply airflow
Yes.
rate and also for the ventilation airflow rate. Okay.
Yes.
So
Yes.
based on the airflow rate, you are going to find out the coil load. That is called that sensible load and the latent load and also the total load, right?
Yes.
Okay, you have a different type of AHUs. You can talk about like the direct AHUs with the heat wheel, without heat wheel, then with the heater, with the horseshoe pipe, okay, pre-cool and
Yes.
preheat. So you will be finding out
I
basically. Yeah,
believe that you also explain about which software you will explain for the energy recovery wheel.
yeah. There are actually you can talk about there is a DRI software is there. Okay, you can enter all the
Is
data.
also you
Yeah,
are referring to EcoFresh?
there is a DRI, right? DRI.
DRI, yes.
Okay, so the DRI is a heat wheel manufacturer. So based on that heat wheel manufacturer, you can able to decide what is the on coil and on wheel and off wheel based on their efficiency. Okay, different manufacturer have a different
So,
efficiency.
so you will provide the software as well,
No,
or
it's
I need to
online.
arrange
It's online. It's online to open to everyone.
online? Hmm.
Okay, so based
What
on
about
that,
the heat through pipe? Because I know there is a software for that as well. So I will get from your side, or I need to arrange from my side.
no. See, it is all available in the internet directly. Okay, so if you search
Hmm.
heat pipe software, it is available. Say for example, different manufacturer they provide open, right? You no need to log in or something. You can directly access.
Hmm.
Okay, that also we will discuss. We will discuss during our class. We can go by step. Okay, so you will start with architectural package. You will start learning the architectural package, how to do the space planning. Then you will talk about codes and standards. You will be referring that. Then we will go step by step like thermal load calculation. Then we will talk about fresh air calculation, generator ventilation calculation. See, whatever you are doing calculation, maybe I'm sure that you will be just entering the value. For example, when you are working in the project, what you will do, you will calculate the area. You will just enter the value in the HAP software. You will just try to find out the result, right? But we are going to study that each and every input, every output, how we are going to generate as a equation. There are different equations for different, say for example, different system. Okay, for example, lighting load, how to calculate the lighting load heat dissipation, how to calculate equipment heat dissipation, how to calculate envelope heat dissipation, what is the equation. So we are going to discuss each and every item step by step. Okay, so based on that step, you will learn the basic understanding. Say for example, if you are doing transformer ventilation, okay, what is the general local regulation says that. Okay, it is not that just you will enter the value, you will get the output. Okay, that is the fan capacity. It is not like that. What is the transformer ventilation? What it says, why the transformer ventilation, how the value came from. So these all the things we'll be discussing. Okay, basically.
That I need, because what I can say, because I am working in IBA since I think more than 1.5 year.
Okay.
So basically, I believe that you will refer UAE fire code. So I am also much aware about UAE fire code. Not
Okay.
in deep.
Okay.
What I need from you, because whatever I know, that's I know. But I need to go
Understand.
in deep. I believe
Yeah.
that, and also I want to expedite. I will not move very slow like this. We need to be go fast so that I can collect all the knowledge in very short period, because I cannot give any more time on here or something like this. So I hope you understood what I want exactly.
Yeah, understand. So we will be going through like, say for example, I will be sharing a lot of recorded videos. To go through the video, then we
Hmm.
will have a discussion on the technical clarity. Say for example, your
Yes, yes.
questions. Say for example, I will be sharing some videos for thermal load calculation.
Hmm.
You can go through the video, come up with the questions.
Hmm.
Whatever you have a query, we will discuss that queries.
Hmm.
Because say for example, thermal load calculation, you already know how to do the HAP calculations, right? So we
Yes,
will
yes,
be
exactly.
discussing on basically on your queries each and every class. Say for
Hmm.
example, we have a 13 or 15 classes, okay, for the air conditioning and ventilation itself, okay, as
Hmm.
a folder structure. So say for example, if I go to one of the folder structure for the air conditioning and ventilation.
Hmm. Are you opening any folder?
Yeah, I'm going to open one folder. I will be sharing it to you.
Please.
Say for example, can you see the folder? Can you see the screen? No.
I can see the screen, but the folder I cannot see.
Okay, let me share. Let me stop share and I will be sharing it again.
Okay, okay, no issue.
Can you see the folder now?
Yes, yes, I can see it.
Okay, so this particular folder, you can see that architecture, space planning, codes and standards, introduction about air conditioning, psychometric calculation, thermal load calculations, fresh air calculation, AC equipment.
Can you please elaborate more what you will explain in psychometric calculation?
See, psychometric calculation, say for example, if you go to, if I go to inside the design guide, right, I will have a,
Uh-huh.
there is a, say for example, there is a psychometric chart from carrier, for example, okay.
Yes,
So if I
yes,
open this particular chart, normally remember when you go to the psychometric chart, you have a different properties like dry bulb temperature,
yes.
wet bulb temperature, specific humidity, enthalpy. Okay, then you will be having relative humidity, dew point temperature. So basically, you will be discussing all this particular items. Say for example, let me 1 minute. I will just try to open.
Yes, yes. Because what I want exactly, see, I am doing the calculation, so I also did the FAHU, AHU, FCU. But how I will get that this is accurate and any the function of this FAHU or AHU will be proper, there will not be any condensation or something like this. That I want to check in the psychometric, and how I will check that. I want to learn in deep the psychometry. That's my aim here.
Yeah, what I'm saying,
Okay.
see, for example, when you want to learn the psychometric chart, see, I will tell you something. One more thing, it is not able to quickly learn like within 1 week or within a short period.
Yes,
It's not
yes, I
possible to
agree on
learn,
this.
but it is the more effort from your side. Say, for example, when I tell you to read some documents, so you really go to read and come up with your clarifications. Then we can discuss in detail so that you can able to understand like. What is your query, what type of knowledge you require. So that type of thing we can discuss, right?
Yes, yes, correct. I
Okay,
agree.
but yeah, but it's not that we cannot cover it in very short time. It's a very long term course. Actually, before like 1 year back, I was teaching like for as a one package. but recently it's very difficult to cover for 1 year package. Okay, say for example, this is the psychometric chart. Okay, so you can say you can able to see the you can able to see
No, I cannot
my,
see the chart.
yeah, this is
I
the
can see
problem
the
with
screen, but chart, I think.
yeah, yeah, that is why I don't prefer I always prefer Teams meeting, Okay, see for example, when you go to you can able to see now.
Yes, yes, I can see
Okay,
now.
so this is the psychometric chart. I will ask you to read. Okay, it's not able
Yes.
to read, within a short period, but you can able to take your time to read. It's a proper. This is the basic when you are a HVAC engineer, right? This is psychometric
Yes.
chart.
Yes.
Go through the psychometric
Yes.
chart inside. Try to understand what is psychometrics.
Hmm.
Okay, what is the properties of air and vapor. Okay, how the
Hmm.
humidity and source, temperature and pressure. Okay, and what is the psychometric chart says, like a dry bulb temperature scale, dew point temperature
Hmm.
and saturation line scale, relative
Hmm.
humidity,
Hmm.
specific volume,
Hmm.
right? Then you will
Hmm.
talk about sensible and latent heat changes, sensible heat
Hmm.
factor, okay, then
Hmm.
humidification and dehumidification, cooling and
Hmm.
dehumidification, right? Heating and
Hmm.
humidification. So these are the understanding you will study in this particular guideline, right?
And see one more thing. You explain any sensible heat ratio, these all factor which we have here. So I believe that you will, the one we will study here, you will relate with the ASHRAE. And you will show me ASHRAE, we need this inside to the comfort zone, and we are getting this. So how we will improve? You will refer to the ASHRAE every point. Uh, am I right?
Uh, I didn't get you what you're saying.
Let's say sensible heat ratio, how much it should be for the comfortable zone, because when we are calculating the FAHU, so sometimes it is coming zero point 0.3, sometimes it is coming zero point 0.8. So what should be as per the standard, and the standard that we will follow, this should be the ASRE. This one I am expecting from you.
Okay, see, basically, I will tell you that not all spaces are uniform. Okay, say for example, when you go to
Okay.
the kitchen spaces, you have a different temperature. When you go to the residential, you
Yes.
have a different temperature. Okay, so these are the different spaces. Okay, even though, for
But
example, if I see
we,
the residential project,
we will refer ASRE, right?
yeah, we will be referring
We will
ASHRAE,
refer.
but the actual will be based on the based on your actual calculations, right?
Yes, yes, correct.
Okay, see, for example, if you go to, let me open one more guideline, okay, so that you will be clear. Uh, uh,
Because I want to kill the subject. Yeah, I want to eat ASRE. That's my aim.
yeah, we can,
Because
but
here, whenever I am going anywhere for the interview, so uh, I am covering if they are asking. But sometimes I am getting stuck in my work, so that's I don't want. Everything should be net and clear. If anything I want, so it should be referred to the ASRE or UE fire code or NFPA like this. That's I want.
yeah, that is what we have to normally go through all the guideline first, okay, so that you can able to basically you have to read the guideline that will be telling you step by step. Uh, say for example, if you talk about ASHRAE 55, can you see here thermal environmental for
Yes,
condition for human occupancy? So this
human
is the what we
occupancy.
will
Yes,
be
I can.
referring. This is the what we will be
Hmm.
referring. You can able to see right now.
But this one you are referring for the energy, right? Or you are referring for the calculation and other thing?
No, see, this is the guideline. Basically, this is the
Ah,
guideline.
yes, yes.
Okay,
Comfort
so
zone, right?
it is not that they will be giving directly the equations, but we will get some
Yeah.
informations from here, right? Say, for example,
Hmm.
when you do the heat load calculations, say, for example, what is the temperature requirement for the human being, right? So you can say
Yes.
normally 22.5 degrees Celsius, okay, and
Hmm.
this is the
Hmm.
temperature requirement, okay. So if you go further, the evaluation of comfort in existing
Hmm.
buildings, okay. So these are the
Hmm.
guidelines, right? It
But
is
why
not
you
that
are
we
referring 2013?
I don't have a latest one, but but it's a basic, right? Each and every guideline will have a same slight modifications, right?
Yes, yes. But
You
I remember, there is too much update in the current because the chart you are showing me, uh, there is a clothing label and these all factor, and there is a other method that I studied recently because we done one outdoor air conditioning. In that we I studied. So there is too much changes. If you will refer 2013, so when
so
in the
what is the
updated
stand?
version,
So what is the standard you are referring? Can I know?
I think it was 2019. I'm not sure. I will send you because I have that PDF I can share with you.
Okay, understand. Yes.
Yes.
Okay, so
So I
if you
think we
go
need
for,
to go to the
yeah,
updated version.
yeah, sure, we will go through that updated version. Okay, so if you go
Yes.
further down,
Hmm.
there is a thermal load calculation as well. Let me open another guideline.
Hmm.
So this is the ASHRAE guideline fundamentals.
Hmm.
So here you can see the psychometrics here, right?
Yes. Yes. Yes.
Also for the heat load calculation, see the load calculations and energy requirements. Okay, so
Hmm.
here section 4 you can refer.
Hmm.
This is a psychometric chart. This is the sensible heat ratio to how to find out sensible heat ratio. Can you see here? So this is based on the
Yes. Yes. Yes.
actual load on the space. Okay, you have a different latent load, different sensible load. So based on that, we can able to understand what is the conditions, right? The apparatus dew point
Hmm.
temperature.
Hmm.
Okay, and this is the uh, if I go further down, this is thermodynamics and refrigeration cycles. Okay, so
Hmm.
if I go further down, this is the heat transfer equation, right? Remember, whenever we do the calculation, heat load calculation, we have a convection and convection. So that equation will be applied for the envelope, right?
And I think there will be radiation as well.
Yeah, radiation as well, yes.
Yes. So yes, we are applying that formula.
Yeah, so we are referring this formula for the our calculation, right? Basically, whenever you do the heat load calculation, we will be
But
referring,
just one
yeah,
question:
yeah.
what would be the advantage if I will learn these are formula? Because I am using software, so I will put the
No,
value
no.
and get
See,
the answer.
whenever see what I'm saying. Whenever you apply in the software, maybe it's
Hmm.
just like calculator, right? But to understand basic information, say for example, when you have a convection and convection, so how it works.
Hmm.
So basically, you should understand,
Hmm.
right? When you're a
Hmm.
HVAC engineer, but it's
Hmm.
not that no need to go in depth, but to basically to understand what is the equation, how it works, right? The
Hmm.
different wall thickness have a different heat transfer, different ambient temperature
Hmm.
have a different load. So because basically the
Hmm.
outside temperature is basically affecting your inside spaces, right? So how this equation
Hmm.
came from? Okay,
Hmm.
normally you heard about Q equal to mc by delta T, right? So that is a basic
Yes.
equation for the HVAC. So from that equation
Yes.
they develop many formulas, right? Say for example, if you
Hmm.
go through, if you elaborate here, this also will be look like Q equal to mc by delta T, right? Say for example, Q equal
Hmm.
to mc by delta T. So that type of equation
Yes.
which comes from which we using for convection, conduction, right? And say for
Hmm.
example, when we have a heat flux, okay,
Hmm.
interface resistance. So these are the equations, heat transfer equations for the envelope. Okay, see for
Hmm.
different, say for example, when we have a pipe, okay, so what is the
Hmm.
insulation thickness, how we calculate normally the insulation thickness based on the heat transfer.
Hmm.
Okay, can you see this is the liquid and this is the outside area and this is your pipe,
Hmm.
like pipe material thickness.
Hmm.
Okay, so what is the equation to calculate, how to calculate the thickness of the insulation based on this equation, right? So
Yes.
when you approach insulation supplier, they will be using this equation to calculate the insulation thickness. Depends upon the outside temperature and internal temperature.
Hmm.
So when you go through this particular guideline, you have a normal, you have a different equations and the explanation on the equations.
Hmm.
Clear?
So we will go. The conclusion is we will go in deep as well. Yani we will. You will show me the example that this is the value we are using. So we will get this much of critical thickness. I believe that you are referring to the critical thickness. How we will calculate, right?
Yeah, yeah. See, actually, it is not continuous discussions. You'll be studying
Hmm.
normally, basically from your side. Will be guiding
Hmm.
you. Okay, we cannot discuss everything in within the short period. It will be, see, for example, if you have a
Hmm.
thousand hundred, 1100 pages,
It
right?
is
So each and
1100. Yes.
every
Yes.
discussion it will take a long time. But what I'm saying, we
Exactly.
will discuss about
Hmm.
specific items. Okay, see, you have
Yes.
everything to read, right? You have everything to read.
Yes.
But for example, when you design the thermal load calculation, HAP calculations, so what is the equation you basically you calculate? What is the equation you will use it, right? So that equation
One
comes
more
from
question.
ASHRAE
One more
guideline.
question.
Yeah.
One more question. Actually, to be honest, I am always worried. Yani, whenever I am doing any design, so there are many standards. So I always get confused which one I will select. Sometimes I go to, let's say, to the public health. So we have
Okay.
uniform plumbing code, we have UAE fire code and ADM. So I
Okay. Okay.
always think if I will study ADM, I will refer to the ADM. So I cannot. I cannot learn the uniform plumbing code. So what is your conclusion on
See,
these all? Because you
okay.
already
See,
have
what
done
I'm
so much.
saying depends upon the location to location. Okay. Say, for example, if you are in Dubai, you have a Dubai building code, right? And if you are in
Yes.
Saudi, you have a Saudi plumbing code. Okay, or you
Mm-hmm.
can say that Saudi building code. Okay, and
Mm-hmm.
You have a Dubai building code. Then you have a green building regulations. Okay, if you go to Abu Dhabi, you have
Mm-hmm.
a Abu Dhabi like uniform plumbing code Abu Dhabi. Then you have a stormwater Abu Dhabi code. So different locations have a different procedure. Okay, but ultimately the it all come from international standards, which is called international plumbing code, right? Or
So
you can say that building.
conclusion is I need to study in deep the international code, right?
Yeah. Basically, yes, that is the conclusion. But as I say that you can't learn everything in short period. I understand that you are faster, but you can't learn everything in within short period. You have to go step by step, like it's drop by drop. Okay, you understand, right?
Yes, yes, I agree.
Okay, so what we are going to do, I will be telling you like step by step what we are going to learn and what we can discuss. Maybe we can discuss like weekly 30 minutes. Okay, to discuss about your clarifications. Maybe I cannot say that I will be
No,
knowing
I think
100 percentage.
30
Yeah,
minutes will be very less. I think the question that I would have if I will watch your videos 1 week, it cannot be resolved within 30 minutes. So I need more time.
yeah.
I
If
mean
it is more
minimum
time,
one
yeah. See, that is what I said. We will go with another way. I cannot cover everything in like the amount what we have decided, right? So we will have a
hour.
different options. Like maybe we can have a monthly package, right? Monthly, this is the
Mm-hmm.
package. So we will be discussing continuously per month whatever technical queries. Say for example, you can come up with some questions, so I can answer it. I can prepare for your answers and I can deliver it. Okay, but what I'm
Mm-hmm.
saying within this short period, we cannot cover all the syllabus in within the short period with the current package.
Just one question. What
Yeah,
do you think, how long it will take if we will go slow, one
no.
year
What
around?
I'm saying, no. See, you want to learn or you want to, you can't become a master within the short period. That you agree, right? So, see, for
Yes,
example,
yes.
I'm in 20 years in experience in MEP industry, but still we are learning.
Mhm.
Still we are learning
Yes, yes.
new things. Okay, so what I'm saying,
Mm.
we will go like what you need to deliver your projects. Say for example, you are in a HVAC field, right? So in the HVAC field, you
Mhm.
are doing thermal calculations, only thermal calculation. So when you talk about
Mm.
ASHRAE, it is only HVAC, it is only heat load calculations, right? So
Correct,
when you talk
correct.
about the building
Yes.
industry, you have a lot of things to learn. Okay, if you want to go
Mm.
in one depth, you cannot end, you cannot finish it. There are a lot of things. If you go to ASHRAE book, see 1100 pages, right?
Yes, yes, correct.
This 1100 pages you want to study, which is not possible. Okay, so what I'm saying that what is required to deliver your projects, only we will focus on that.
Yes, correct. I agree.
Okay, so that one you can give me that say for example, I want to have idea about this particular items, so I can prepare it so that we can discuss in the
Mhm.
discussion, or maybe we will discuss what is your requirement for this week, then we can clarify it in the
Mm.
next week, something like that.
Mhm. Yeah, I agree.
Okay, so this is the basic training course. Who don't know like what is HVAC or what is say for example, they are new in engineering, they are new, they are contractor side, they are in some
Mm.
other suppliers, so they want to learn the HVAC calculations. They will be learning it. But since you are in a
Good.
consultant already, you want to go to the deep depth of the codes and standards. Actually, having a multiple codes, there are different codes, right?
Yes. That's also my point. See, if for the ventilation calculation we have actually
Yeah,
62.1.
62.1. So in
The,
that 62.1, what is required? Only we will take that one.
mm.
We will not be discussing each
Okay.
and every pages which we cannot cover it. Maybe
Mm.
it will take months, not months. It will take years.
Correct. I agree. That's I was worried. How I
See,
will
say for
cover all the
example,
topics.
you are a person, okay? So you want to learn something about heat transfer. So what I'm saying, just to go through this particular one, okay? You think about this.
Mm.
What is solar absorptivity? Okay, maybe we
Mm.
never use all this information in our day to day times.
Yes,
Okay,
correct.
maybe it's
Mm.
not required to read, right? For example, when you talk about insulation, okay, so how to calculate the
Mm.
insulation thickness? Yes, that we can teach,
Mm.
right? Okay, so you want to
Mm.
know what is the envelope calculation? Say for example, this is the emission value, right? Say for example,
Mm.
emissivity of
So what is
CO2 and
envelope
water.
exactly?
What is that? Envelope is nothing but you have a wall, you have a floor, you have a roof, So that is called
So
envelope.
let's say if we need thermal properties, so we are asking from the architect what would be the envelope value like this.
Yeah, envelope value, but basically if you go to the code, they also given the value, right?
Hmm?
If you go to ASHRAE or if you
Yes,
go to
yes.
local green building regulations, already available,
Yeah,
right?
yes. You're referring Istidama green building design, right?
Yeah, we have a green building
Istidama.
regulations. Yeah,
Yes,
yeah.
yes.
Okay, see, for example, here we will talk about thermal convection here. There is a equation. Okay,
Hmm.
so we never use this equation here. Okay, but we cannot
Hmm.
learn each and every items. Okay, what is required, we will be
Hmm.
studying that one. Say, for example, there is a heat
Yes.
exchanger here, right? So heat exchanger, what is
Hmm.
that? Q equal to UA delta T. Because heat
Hmm.
exchanger having a it's a thermal wheel, right? Heat exchangers, you can say that
Yes,
this
yes.
is like a, you can say that say for example thermal wheel, assume thermal wheel.
Hmm.
Okay, so in the
Hmm.
thermal wheel depends upon the thickness of the wheel, you have a different heat
Hmm.
transfer, right?
Yes.
Okay, so we will be discussing
So,
uh, what is required to deliver our
just one
projects.
question, please.
Yeah, yeah,
Just one question, please.
yeah.
See, in my project, we have villa and we have high-rise residential towers.
Yes, yes, yes,
So
yeah,
I have one always confusion, yani
yeah.
how we are deciding that we can go with the heat recovery wheel or heat shoe pipe. How we are deciding this one based on ASHRAE and what is the maximum value that we can go with the heat recovery? Because as I know, if the capacity is too low, we will go so operational cost will be more. Yani there will be more electricity. There will be additional electricity. So how we are deciding this one? Yani we can go with the heat recovery wheel. Is there any
Uh,
standard like this?
Yeah, see, I will tell you, this is based on the manufacturer's guideline. Okay. See, when you talk
Mhm.
about standard, they will tell you that what is the heat transfer which is happening in the heat wheel. Say for example.
Mm,
Okay. And if you go with
mm.
the pre-heat pipe, what is the efficiency? Okay. So basically,
Okay.
when you want to go with the fresh air conditioning unit, you have a different options. Okay. One, you can go with the
Mm,
enthalpy wheel. You can go with the sensible wheel or plus enthalpy
mm,
wheel. Okay. Another option, you can go
mm.
with the horseshoe heat pipe wheel, right? So as a
Yes.
manufacturer, they will run for all the options, and we have to, as an engineer, we have to choose which option is best suitable for our project. It is not all are same.
Just one.
Different project
So
having a different requirements.
yes, yes. The thing you are explaining, it seems like once I have any project, let's say I have 1,000 liter per second fresh air. So I need to send to the manufacturer, then he will decide which wheel we need to use.
Yeah,
So it
yes,
means
because
that
yeah,
if
yeah.
I will be in a meeting, I will be in a meeting and the client will ask directly to me. So as an engineer, what I will advise, I cannot say to him that I will wait up to the manufacturer will send the selection.
So okay, I will tell you one more thing. See, when you use the equations, okay, you cannot say that whatever the equations you are using, it will be general.
Hmm.
Okay, it will be general.
Okay.
Okay, okay. Say manufacturer having a different materials, right? Different efficiency.
Hmm. Hmm.
Okay, so
Hmm.
for the as an engineer, we can use the equation to calculate your value. Okay, but which is a generic value, which will not be a perfect
Hmm.
value for the client. Say for example, today
Yes,
you are
yes.
saying as per
Yes.
the equation, you will say that heat
Hmm.
wheel is a good option. But when you go with the manufacturer, they will come up with the pre-heat pipe is a good option. Then what you will say to the client? You will tell him that
Yeah, I
I am
agree. But
using the ASHRAE guideline. I got the equation. So based on the equation, I got this value. So I will go with that value.
hmm.
No, it is based on the manufacturer guideline. See, always as a consultant, we are not depending upon the equations. Always, okay. But the
Hmm.
equation will be for the to get the designed values. But always, whenever you
Hmm.
go with the final IFC package, you have to always refer to the manufacturer, right?
Yeah, finally, what we do generally, we calculate it, then we send to the manufacturer for their selection.
Yes,
Because
yes,
sometimes they are asking for the noise label and these all things. So,
yeah,
but
yeah.
we are deciding, we are sending, we need this heat recovery, we need this preheat pipe. But you are saying that you will send to the manufacturer and take their advice. So this is making me confused. That's
No,
my question.
no, that is the right way. That is the right way to decide to finalize it. Okay, you cannot say
Hmm.
that. Say for example, you can decide. Okay, you can go with either heat pipe or you can go with the preheat pipe. You can decide, but
Hmm.
how you will
Hmm.
conclude? How you will conclude? Okay, so that is it
You mean
depends upon,
how
yeah,
much we are saving these all things?
yeah, how much we are saving. Say for example, sometime you go with the heat wheel design. Okay, that heat wheel
Hmm.
maybe
Hmm.
that heat wheel maybe it will not work because of the supply temperature and return temperature what you are expecting, and it depends upon the supply
Hmm.
airflow rate and the exhaust airflow rate what is your requirement, right?
Hmm. Hmm.
So it is not
I
that
agree, but still
yeah.
Hmm. I
So
agree with you, but still I am confused because let me explain you why I am confused. In
okay,
my all project, let's say if we have villa, so in the villa we
okay,
are proposing only heat through pipe, yani we have pre-cool and reheat. In
okay.
the
Is it a
high-rise
one way?
project,
Is it a one way or is it a one way or two way?
for the villa we have one way, yani of
So
course
one
there
way,
is
it's
pre
okay.
pre.
One more thing.
Uh,
One more thing. When you have a one way, then why you talk about heat exchanger, heat wheel?
no, I am talking, yani, even if we have two way, yani, the high rise project, the one we have done, so we have used both, yani, heat recovery wheel and heat through pipe, yani, pre-cool and then reheating like this.
No, no, no. See what I'm saying. This depends upon the manufacturer to manufacturer. Okay, you think that all the manufacturer will give you the same efficiency?
No, they
Yeah.
will have different
Yes.
efficiency.
So that is also the basic guideline, right? As a consultant, we should always verify with the manufacturer what is available in the market, right?
Mm-hmm.
Okay, today you done one equation. Okay, based on the equation, you have
Mm-hmm.
decided that heat wheel is the best efficiency based on the equation, right?
So what I need exactly, you will teach me how we will, yani, you will teach me the better way how we can advise to the client or anyone which, yani,
Yeah. See, I will
after
tell
I
you
will take
that.
the.
Yeah, as a
Uh,
consultant, we always depend on manufacturers. I'm not talking
yes, yes,
about suppliers, right? As a manufacturer,
mm,
what
yes.
technology is available? Okay, so as a
Mm,
consultant, we are working as a consultant. Okay, we
mm,
always we do the design calculations. We have a value,
mm,
but that value is not the final value. Do not go with that
yes.
value. Okay, always you have to
Mm,
verify with the manufacturer, multiple manufacturer. Say for example,
mm,
when I designed the, say for example, I will tell you one small information. Okay, say for example, I am
mm.
designing chiller, for example, right?
Yes,
Okay, so chiller having a COP of 2.8, right?
2.8 or 3.4. I don't know exactly.
No, 2.8 as per the guideline. Okay.
See, in I yesterday I sent yani, for the equipment selection to the carrier. So
Mhm.
we are asking three COP.
No, no, that's what I'm coming to you. What I'm saying, when you say
Okay, okay, okay. Please.
as per the local guideline,
Mm-hmm.
2.8 is a
Mm,
requirement, right? But when you go with a
yes.
different manufacturer,
Mm,
okay, you will choose
mm,
someone will give 3, someone will give 3.4,
mm,
someone will give
mm,
4, for example. So which one you will choose?
mm. The higher one, the higher we have, so we
Yeah.
will select that manufacturer.
So why you didn't tell your client that I'm following as per the standard 2.8?
Yes, yes, I agree with you. Yani.
So this
Now
is
you
the
conclude
Yeah, so this is
clear.
the way we have to design each and every project. Always don't go with the equations and always don't go with the manufacturer guideline, but we have to balance both, right?
Yes, yes, I
See
agree.
why there is a guideline? That guideline is for the minimum requirement. You cannot go less than
Yes.
2.8. So we are
Mm-hmm.
putting
I
a full
agree with
stop. Okay, but always when what we are choosing 4 because the 4 is the highest efficiency, right?
you. So after yani, once we will advise 2.8, yani after our calculation, we will send to
Yeah,
the
yeah,
manufacturer
yes, yes. So
and we will select the
when you
higher
do the
one.
yeah, yes. Now we can say that yes. When you prepare the equipment schedule for the chiller, you will prepare your motor
Mm-hmm.
power based on 2.8. But after you send to the
Mm-hmm.
manufacturer, you will get different values. So you will
Mm-hmm.
do the comparison between the manufacturer and then you will choose which
Mm-hmm.
is the best one. So based on the best one, you
Yes.
will modify your equipment schedule. Clear?
Mm-hmm.
So
Yes,
this is
yes, clear.
applicable for
The
all the
same.
product. This is applicable for all
Yes.
the product. Like you have a
Mm.
pump when you do the pump flow rate. What is that? GPM equal to like TR multiplied by 24 divided by delta T, right?
24, yes. Yes.
Yes. But when you go with a different pump, there is a different efficiency, right? You have efficiency also matters.
Yes, yes, correct.
Okay, so depends upon the manufacturer, you will choose that which efficiency, right?
So do you will provide the any manufacturer numbers or something like this? Because what I know only carrier.
Yeah. Which one for the
Have any
pumps?
contact number? Yes, pump and chiller.
Yeah,
Just
we can discuss. See,
name we can discuss.
we can discuss like
Mm,
for your ongoing supports. Like basically, whatever you need a support for your ongoing job, we can discuss. Okay, and I will.
yes.
I also have a one group WhatsApp group. You can also put your
Mm,
whatever your thoughts, whatever your questions. Maybe we will not answer it, but we can able to clarify your queries. Clear, right? So this is what we teach.